Dietz asks us to consider something radical. What if gravity isn't pulling you down, but balancing you within an invisible field? He proposes that gravity emerges not as a fundamental force, but as a displacement within a zero-energy equilibrium field. Instead of masses attracting each other, they create ripples in a cosmic balance that nature constantly tries to restore. This isn't just another interpretation of Einstein. It's a framework that connects gravity, energy, and time through a single principle. The universe seeks equilibrium. In this framework, empty space is a zero-energy equilibrium, a quantum vacuum. When mass appears, it displaces this field, creating potential gradients. Gravity is the field's attempt to restore balance. This is described by F, which shows how steeply the field is displaced. This framework adds another layer to time dilation. Local time rates depend on the internal energy transformation rates within matter itself. An atom near Earth transforms at a different pace than one in deep space, because the field displacement alters how quickly its internal processes occur. Time becomes a measure of change, and change depends on the local field state. This reshapes our understanding of the early universe. Instead of a singular explosion, consider energy bubbles forming within the equilibrium field, regions of varied energy density. Cosmic expansion was the field's dynamic response to restore equilibrium. This drive for balance manifests as the motion and large-scale structure we observe today. If gravity is really about field interaction, could we shield it? This framework introduces a shielding coefficient, a factor that might reduce how strongly mass couples to the equilibrium field. Consider quantum levitation. Superconductors expel magnetic fields through the Meissner effect. Could a similar mechanism exist for gravitational fields? By reducing the mass field interaction, objects might experience reduced gravitational coupling, not conquering gravity, but partially decoupling from the field that mediates it. Now, push to the extreme, black holes. As you approach an event horizon, field displacement becomes so severe that time nearly stops. Clocks tick slower because internal energy transformations, the processes that define the passage of time, approach zero rate. At the horizon, the field displacement is so complete that internal change cannot occur. This isn't just relativistic time dilation, it's the suppression of transformation itself. This examines regions where the equilibrium field is maximally displaced, where the universe's drive toward balance confronts its own limits. In a universe of shifting fields, gravity, energy, and time are the language of change seeking balance. This framework presents these not as separate phenomena, but as expressions of a single principle. Displacement creates imbalance, and nature responds. Whether it's an apple falling, a clock slowing, or the cosmos expanding, it is the same story. Equilibrium disrupted, equilibrium restored. The equations may be complex, but the idea is elegant. Everything flows from balance.